Hello everyone, this is D. Chiranjeevi, Assistant Professor, Department of Information Technology, Aditya University. Today I am going to discuss programs using functions. So in this lecture, the learning outcome is student will be able to apply functions concept to solve real-time complex problems. The outline of this lecture is, I will discuss a program to perform reverse of a number, and then I will discuss a program to check whether a number is prime or not. So the first program is reverse of a number by using function. Okay, now let's understand this. So this problem can be done in 4 ways. So all 4 user defined categories you can use, but here I have solved this by using function with argument and no return type. No return type means void. Okay, so here the return type is, I have written no return type, that is void, and function with argument. So function name is reverse, I passed a argument, that is int. So we are performing reverse of a number. Let's say a number, so n, let's say I have taken here 345, so only one number I have passed. Okay, that's why I have given only one argument. Okay, this number I want to reverse. If I reverse, I will get 543. So I have passed one argument. So the program execution, okay, will start from main function. Okay, so one number must be there in the main function so that it will be given to user defined function to perform the reverse. So the program execution start from main function. So user read the value n, that is 345, will be stored here in the n. Then after that, next line function calling. This is function calling. Okay, so when the control reached this line, from here it will directly go to definition. Okay, so now this n value here 345 will be passed to here int n. Okay, so this n value will be passed to int n. Okay, so n value you got 345, so you have taken a variable that is REVE value 0. Okay, now when, how can you reverse this number? So this number must not be 0, right? So must be greater than 0. So any number which is greater than 0 you can perform, or you can also write logic not equal to 0. Okay, if a number is negative, then also you can perform reverse. Okay, but here only positive numbers I have written this program. So now to reverse this, we need to get the remainder of the number. So remainder will be get by performing the modulus. So that remainder value storing purpose I have taken REM variable. Okay, so then the control will go to next line while n not equal to 0. N value is 345, so not equal to 0, true. So you are performing remainder. So remainder, how much will you get? So if you perform modulus, now 345 by 10, you will get 5. After that, what you are doing? So reverse value you kept 0, so 0 in 10, 0 plus remainder, so 5 you will get as remainder value. Then after that you are updating n, so n 345, if you by 10 if you do, you will get 34. After performing this, again it will go and check the loop condition n greater than 0. So updated n 34, 34 greater than 0, true. Again you are performing modulus with 34 mod 10. So this time this remainder will be updated with 4. Now after that you are finding the reverse. Already updated reverse value 5. So 5 into 10, 50. Then remainder value 4. So now this updated reverse value you got 554. After that n by 10. So 34 by 10. Now you will get 34 by 10. You will get 3. Okay. So 3. Now again it will go and check 3 greater than 0. True. So 3 mod 10. You will get remainder 3. And updated reverse value is 54. 54 into 10, 540 plus remainder, that is 3. So you will get 543 updated value, REVE value. Then n by 10, so 3 by 10 you will get updated value 0. Now again it will go and check in the condition 0 greater than 0, false. Now by the time you already reversed the number which is stored in REVE variable. So then you print REVE variable. Okay, so it will give 543. Okay, so 543 is the output, 345. So this is how by using a function you can reverse. So because this function is no return type, so you are directly printing this REVE. If it is return type, simply instead of printf, what will you do? You can simply write return REVE. Okay, it will return to this from where you called. Now after printing, it encountered the curly brace, so it means REVE function execution is done. So it will go back to from where you called. So you called from REVE of n, So it will check this function is done its job. So then return 0, it means main function execution is also over. So it will terminate. So the next program is a number is prime or not by using function. So now let's understand this. So this is also we have done with argument and no return type only. Okay. So I have taken the no return type, void data type, then prime is the function name, and you are checking a number is prime or not. So one argument I need to pass, so I passed as int. Then so one number must be in the main function. So program execution will start here. So user read the a value, then in the next line user called the prime function. So when user calls the prime function, so the value which you read in a, so that a value, when you call the function from here, it will goes to this function and reach to this a value. Okay. So a value will be passed to a. Now when will you say number is prime? So here we will be having three cases. So the first case is case 1. Okay. So when you start from I equal to 1 and you goes up to I equal to n. Okay, I equal to n. It means 1 is the factorial, n is also having the factorial. So in that case, count value is 2. This is one case. Case 2 is you start at I equal to 1, you go up to n minus 1. In this case, only 1 is the factorial. So count value will be 1. Case 3, you start at I value 2 and goes up to n minus 1. In this case, count value is 0 factorials. Okay. So when you start at 1, you go up to n, then in that case, the number of factorials for that number is 2, 1 and n itself, number itself. When you start at 1, but you go only up to n minus 1. So you are not checking with n. So in that case, only 1 a number is divisible. So in that case, count value will be 1. Third case is you started at 2 and checking up to n minus 1. Neither 1 nor the number itself. So here in this case, count value will be 0. So when will you call a number is prime? If a number is divisible with 1 and itself, then we can say that number is prime number, right? So in this case, if any of the three cases you can consider and you can check whether it is satisfying or not. If it is satisfying any of the case, then you can say number is prime, otherwise you will say not a prime number. Okay. So in this case, I am starting at 1, I am going up to the same number up to n. I have written I less than or equal to a, it means I am going up to n. Okay. So a in this case we have given 7. So I value 1 less than 7, that is true. So control will come inside, it will check. Right now a value is 7, so 7 mod 1, so you will get 0. Okay. So 0, this value you will get 0. So 0 equal to 0, true. This if is true, so count plus plus. So earlier you make this counter value is 0, now you are updating count value to 1. Okay. After updating 1, from here control will go back to the loop I plus plus. Now this time I equal to 2, 2 less than 7, true. Now 7 mod 2. If you perform 7 mod 2, you will get the value 1. Now this is 0 equal to 0, so that's why you have updated. So now 1 equal to 0, no. So this is false. So from here only again I plus plus. Now I value 3, 3 less than 7. So 7 mod 3, you will get 1. Now this case also not equal to 0, 1 equal to 0. So this is also not satisfying, this is satisfied. Okay. So again from here only, if only you will I plus plus. Now I value will be 4, 4 less than 7. So 7 mod 4, you will get 3, 3 equal to 0, no, not satisfied. So again I plus plus, I value will be 5, 5 less than 7, true, 7 mod 5. So you will get 2, 2 equal to 0, no. Again I plus plus, I value will get 6, so 6 less than 7. So 7 mod 6, you will get 1, 1 equal to 0, no. Then again I plus plus, I value you will get 7. Then you will check 7. So actually the logic is 7 less than or equal to 7. So everywhere you make equal to. 7 less than or equal to 7, true. So 7 mod 7 equal to 0. So this is also equivalent to, so this is true. So if is true, again count plus plus. Count plus plus, count value already 1, so you will make 2, 2. After that again I plus plus, I value is 8. If I value 8 less than or equal to 7, this is false. When this is false, what will happen? You will come outside the loop, you are checking count equal to 2. So what is the count value currently? 2. So 2 equal to 2 true. So if count value equal to true, so it will print number is prime. So in this case number is prime. So it will print number is prime. So the summary of this lecture is I have explained how to reverse a number, and then I have explained how to check number is prime or not using functions. Thank you.